Thank you and welcome. Now, before I start with the talk itself, I do have a bit of a public service announcement. That is, when you're watching this, it's pretty much holiday season, and do yourself a favor and get together with your friends, family, neighbors, pets, Rust developers, whatever, and watch some Hallmark Christmas movies. They are just meant to make you feel good, and definitely should do it. Though if you're in Europe, you're gonna need a VPN or some alternative means, but do it. It's worth your time. Now, about me, first I was a teaching assistant, and this is back when I was studying as a way to make some pocket money. And when I graduated, I started working as a developer, and 7 years later, I'm kind of realizing not really feeling it. I'm not vibing with the whole Jiras and meetings stuff. So I would actually like to go back into teaching. Now, why am I mentioning this to you? Well, because obviously the point of teaching is that people actually learn something. So I would like it if you learn something from this. So if you have questions, ask them right away. Wait, this is actually pre-recorded. So, okay, you put the questions in the chat, and then the future me is going to be there to answer the questions. Except it's actually current me, and I'm the past me if you're looking at meeting. Yeah, whatever. The point is, I have faith that there is going to be me in the chat answering your questions. And that's the second key takeaway from this talk. Believe in yourself. If you don't believe in yourself, believe in me who believes in you. I hope you get that reference. Now, on with the talk itself. So, how much fun do you think you can have with C++? Let's take fun, like a simple fun, right? This is fun only in name. It's actually quite boring, and any compiler worth its salt is going to optimize it away. So it's quite bland, you could say. This, on the other hand, well, this is infinite fun. And if you do this, then this is even more infinite fun. And the argument I use for that is like the natural numbers and the rational numbers, where both of them are infinite. But between every two whole numbers, you can fit a whole infinity of rational numbers. And if any mathematician listening to this didn't have a stroke hearing that, I would love it if you correct me in the chat. Infinite with terms and conditions, in a sense that you are limited by the hardware and, well, ultimately the fact that the universe is going to end in one day. But still, I would say that's too much fun. And somewhere between zero fun and infinite fun, there is, I guess, the right amount of fun. And I think this is it. This is just the right amount of fun that we should be having. Now, as a note, I will be using bro science. For those of you unfamiliar, it just means that I will simplify things and skip over details, and I will have code examples and things will compile, so things work. But if you go into the nitty-gritty details, may not be exactly as I say it. So if we're talking about all this fun, then, well, there is definitely going to be a party involved. And it's 9 o'clock. This means we are getting ready for the party. Now, for you, this usually means getting a couple of drinks because, well, drinking at the club is usually pretty expensive and you want to be financially responsible. For me, nothing much. Maybe some reading, some video games. And for us together, it's about deciding where we actually want to go to. So how does the compiler decide which function we want to call or which one we want to go to? first things first, you write the name of the function and you give some arguments. And the thing that the compiler does lookup or lookups. Now there is unqualified, qualified, and argument-dependent lookup. Basically, the compiler is trying to find all the functions that are called as the function that have the same name as the function you are trying to call. And for that, if it's unqualified name lookup, and then it's whatever is visible in the current scope. If it's qualified, then that means that you have a namespace before the name of the function, or a class name in case of a static function, static member function. And for the argument-dependent lookup, the function itself is not preceded by the namespace, but one or more of the arguments are from a certain namespace. And so that namespace is also considered when trying to find this function. Now, in a simple case, you have only one function, and then the compiler checks if the arguments you passed are what the functions expect. If they are, if everything is great, you get the call. If not, you get an error. More usual case is that you actually have multiple functions of the same name. Well, more usual, at least in my experience. And in that case, the compiler needs to do overload resolution. So now that the compiler has all the possible functions that you could call, that is called an overload set. And from that overload set, compiler needs to figure out which candidates are actually viable. Meaning, if it were to do some conversions for your arguments, which functions it could call, and then from those viable candidates, it's supposed to pick out the best one, and it needs to be the one. If there are multiple, then yeah, you're gonna have a problem. Now, this is obviously an abridged version, and if you want more details, there are these two talks I would recommend, or just go to CPPRF and read, like, everything is written there. Or if you're like really hardcore, go into the standard, but yeah, good luck understanding that. This would be an example of an overload set. Now we have fun, and we have funs actually. We have 6 of them. First one takes nothing, which actually means it takes void, and the rest take an int, ref qualified or const qualified, or not qualified at all. And then we have a main function, and we want to call all these funs. For the first, it's pretty simple. There is only one. And for the rest, the compiler is supposed to do the whole dance of the overload resolution to call the right ones. And it will do the right thing, except it's not going to compile. It's not going to compile because, in short, and like this is me pro-sciencing it, when you call fun with the A, the compiler is not sure whether it should call the first or the second overload, and it gives you ambiguous overload. Ambiguous call, cannot figure it out, and you get compilation error. If you comment out the first function, then everything is going to work fine. In general, overloading with just the type or the ref qualified type, pretty uncommon and, well, difficult for compiler to work with. And this is how those functions signatures look in the assembly. Left one generated by Clang, right one by the MSVC, although I think this is more about Linux or Windows rather than the compilers. We see that the Clang doesn't include the return type, and MSVC includes the return type, and it even puts a void when you have no arguments. And it also has proc and NP for the beginning and the end of the block that represents the function, which I included here because I think it's nice. The rest is, well, as you'd expect, int, ref, and all that stuff. Now, this is about the lookups themselves. So we have a club, and in a club there is fun, and then there is a party, and within the party there is more fun. And then there is fun that takes a party as an argument, which is where my metaphor pretty much breaks down. No idea how to explain that one. And then there is fun that's outside of the club. And again, we can call all of them. First call is just going to call the fun that's outside of the club because, well, that's the only one that can be found with unqualified lookup. The second one is going to use the ADL because even though fun is not qualified by namespace, party is from the club, and therefore the club namespace is looked up. The third call is going to call the fun from the club because of the qualified lookup. And then if we have a party, or object of type party, and we call fun, then it's a member function of that class. Again, this is how they look in the assembly. You see here that the names of the functions are preceded by the name of the class or the name of the namespace. So we have like club fun, and then we have club party fun, and then the last one is, well, it's just fun. It's fun enough by itself. And here we can play a little game. So you have a party and it has this fun. And you're not allowed to change the name of the function because you cannot have like fun1, fun2, fun3. That's not really fun. You're not allowed to add templates because that's infinite fun. You cannot add arguments and you cannot change the return type, although it doesn't really matter because you can't overload on the return type anyway. And the question is, how much fun can you have? And I will give you a minute to think about it. Not really a minute, I just need the excuse to drink some water. So, okay, there is fun. Well, just imagine that this is within the party. But as not really working for us. So in actuality, there is this all value fun, and then there is the R value fun, and then there is the const all value, and then there is the const R value, and then there is volatile, and then there is all value volatile. And because const and volatile are not mutually exclusive, you have const volatile, all value, and R value fun. If you want to call them, pretty obvious way of doing it. You create either a plain or a const or a volatile party. The volatile party probably sounds the most fun, and const volatile the most confusing. But you have those objects, and then you just call it, or use move if you want to R value overloads. And with that, you can have 8 fun. Well, we will see about that because as far as I know, there is a plan to deprecate, or it's maybe already deprecated, volatile. So I guess they are working on making C++ less fun. Quite sad. It's 10 o'clock, and by this time we made it to the club. Okay, we found the table. We are looking for some place with less smoke. Although I guess in Europe you are forbidden for smoking in closed spaces, so this is more of a Eastern Europe or Balkan issue. And you're wondering something, and that is when we had all those all those regular functions with int overloads, we had an int, we had an argument that we can use to overload, but what exactly are we overloading when it comes to member functions? Well, it's this, this. This is implicit first argument of every member function. So whenever you call a member function, you call it on an object, and this is the pointer to that object, and this is CV and ref qualified, and this is what we are overloading on. And this is usually self in other programming languages, except in C++, and it gets difficult to explain using this and like this and this. Yeah, like maybe I even had some puns, but forgot about them. Okay, there is actually more fun we can have, and there is friend fun and there is static fun. Now, we don't need the friend fun. This sounds maybe a bit counterintuitive because like we went to the club together, so how come? But okay, we have enough friends. We don't need more friends. And this whole like the real treasure are the friends is just nonsense. Okay, like enough friends. You don't need more. But there is static fun, and if you recall, there is static twice in the title of this talk. So maybe there is something about it. So static functions, in essence, are not actually bound to the objects. They are bound to the class or the type itself. Not bound to the object basically means that you don't need an object to call this function, and there is no this implicit this argument, and therefore you cannot qualify it with const volatile or refs because, well, again, there is no this on which you can put those qualifiers on. And well, an example, there is a static fun, and now counterintuitively, even though I just said that you don't need an object to call a static function, this way of calling a static function using an object works in C++. I'm not really sure why and who decided this is a good thing. I'm really not a fan of it, but it's there. The other way of calling it is using the type name and then colon name of the static function. In that case, it kind of looks like you're calling a regular function from a namespace, and that's probably the better way of thinking of static functions rather than this other simply confusing call. However, they do come with one big downside, and that's you cannot have member functions with the same name. You cannot overload. I mean, you can if you have some other arguments, but not like this. The compiler is just going to complain. As a side, there is this thing called like unified function call syntax, which is supposed to allow you to use the same syntax to call member functions and non-member functions. And there are these two really good blog posts from Barry about like what would be the issues of having that in C++. And there is a proposal by Herb to have unified function call syntax in C++. But there is a paper saying that that's like the worst thing and it would break everything. I have not really kept up with the drama. Don't know what's the current status, but I guess you can find out next week on the real proposals of CPP committee. Going back to our party, we see the signatures in the assembly, and if you look at the Clang, you will see that it looks the same as the member function, while MSVC actually puts static in front, so that's a static function. But you see that when the function is called, even like whether you use the object or not, it's the same call to the same function. And there is this part that we kind of skipped over. The address of static member function may be stored in a regular pointer to function, but not in a pointer to member function. Pointers to functions. My friends, it's 11 o'clock, and this is where the best 2 hours of the party, at least my experience, start. Everyone is there. The music is getting actually good. It's getting exciting. And this is where I introduce probably the most important term, well, second most important after Hallmark Countdown to Christmas in this talk, and that is higher order functions. I will give you a second to take notes. So, what is a higher order function? Higher order function is a term used by senior developers to impress the juniors, or a term used by people who studied maths and are working as developers to let you know that they are better than you. This is, source is me. Another source we can consult on this matter would be, well, obviously Wikipedia. And Wikipedia says that a higher order function is basically just a function that either takes a function as an argument or returns a function as a result. And all other functions are first order functions. So we see here that higher order functions have this aristocratic feel to them, like higher order and like peasant first order functions. They are just built different, I guess. The obvious question is, okay, how do we even write a higher order function? It sounds so fancy, it sounds so difficult, so complicated. Well, if you have a first order function, which is just like inferior thing that returns a 3, the way you can write a higher order function is if you live in C++20 world, or in a world that has C++20 or later, you just sprinkle auto. You just say that the argument that this function takes is auto, and compiler is going to figure out what it is, although you write the name of the variable as a first order function to let people know what you expect here. And then when you call it, you call a first order function, and as an argument you pass you call the higher order function, and as an argument you pass the first order function. The names don't actually have to match, and like looking at it now, I realize it might be a bit confusing, but I guess you're smart people, you will be able to understand. Like I said, I believe you. But let's say you are in a land that's before C++20. How would you go about doing this? Obviously, just use templates. Basically the same thing as auto, just you explicitly need to write template type empty, and the call and everything else stays the same. And now we get to the pinnacle of the STL, probably the most beautiful function ever written, and that is std-invoke. You can go to the CPP-ref and find out more about it, but in essence, std-invoke just takes a pointer to a function and then takes the arguments and calls the functions and returns the result. Sounds like a lot of work for something you can do yourself, but it's not really that simple. So let's talk about the pointers to functions. Now, in essence, functions, they exist somewhere in memory. You've seen them in the assembly, so they exist, they take up space. That means they have an address. And if they have an address, you can point to it. And once you have a pointer to a function, well, it's a pointer like any other. You can assign to it, you can copy it, and all the stuff to it. One important thing about the pointers to functions is that if you initialize the pointer to a function using an overload set, the compiler is going to figure out from the overload set which overload exactly matches the type of your pointer. So let's talk first about, at least very briefly, about the pointers, regular pointers. Now we have like integer and a party, and we have a pointer, and this is familiar to pretty much everyone. And the way we look at it is that the int or int star, meaning pointer, is the type, and this is the name of the variable. If we were to write this in one line, then it would be like this. So you would have an int a or a pointer to an int ptr, and the same goes for the party. If you were to put the pointer, well, it should be next to the int, next to the party, but if you were to write it this way, the a and p are not pointers, they are simple integers. So you can, the way I can bro science it the best is that the type is still int or party. It's just that this variable itself is a pointer. And so if you were to have multiple pointers on a single line, each one of them would need to have a star of its own. So let's look at the function. Let's say that this is a variable of a function, like an instance of a function. And if that were the case, we could say that the fun is the name of the variable. Let's just imagine it that way, meaning that the return type and the number and types of the arguments would be the type of the function. So using the logic from like 2 slides ago, 3 maybe, we just need to add the star somewhere around here. So we can put it here, and this would not make it a function pointer. This star, again, would go to the void, and this would be just a function that returns a void pointer. And please don't do that. Do not use void star, please. So we need to somehow bind this star to the fun, to the variable, if you call it that way. And we can just use braces for that. Now this would be a pointer named fun that points to a function that returns a void and takes an integer. And obviously we rename it to putter, because how else are people going to know that this is a pointer? And you don't need the name for the arguments, because you just need the number and their number and their types. If you have a piece of code like this, so you have a fun, and then you want to create a pointer to it, you would write it like this. This is usually a bit difficult to understand, and it's just too different from anything people are used to. So what you can do is just do a using, where you would put a type, and this is, I would say, much more readable. First of all, you have void and then pointer, meaning a star, meaning a pointer, and then you have an int, meaning these are the arguments. And then when you create the pointer itself, it's like a regular variable. It's just of this pointer to a function type, and then you initialize it with the name of the function. As I've mentioned, if you have an overload set, the pointer type needs to match one of those functions exactly. And when you initialize the pointer, the compiler is going to initialize it with the exact function that matches the signature exactly. So the fun putter type 1 and fine putter type 2, two different pointer types. One is initialized by the first overload, the other by the, one pointer is initialized by the first function, the other by the second. And if we go back to the beginning, you remember we had this issue with the fun that's overloaded, that has two overloads, int and an intref. The issue isn't that these two functions cannot coexist. They can. They have no problem with each other. The issue comes from you trying to call it, because at this point, the compiler is supposed to do an overload resolution, figure out which of these is a better candidate, and it cannot. And as a result, you get this ambiguous call error. However, if we, using our knowledge of the function pointers, decide that we don't want the compiler to do the overload resolution, we are going to do it ourselves by creating two function pointers that match each of these functions exactly. We can create them, and then using the panacea of the CPP or STL, stud invoke, we can call these two functions. Bit more, and this comes from the CPP ref itself. Basically, yes, you can initialize it either by giving the address of the function or just the function name. It's the same thing. You can have an array of pointers because they are pointers, they work the same. Fun thing, you can also have a reference to a function, and then when you want to call it, if you have a reference, you just use the variable and then the brackets. If you have a pointer, you can either reference the pointer and then use the brackets for the call, or you can just call directly through the pointer. They work the same. Now, pointers to member functions are a bit more complicated. And that is because now you need to include the name of the type in the type of the pointer itself. And when you're calling this function through the pointer, you need an object, and you need to use either the operator dot star or arrow star. And then there is this whole conversion stuff. It's not really relevant here, so we'll ignore it for now. This would be an example. So we have a party, and it has a member function fun. And this is how the pointer would look. So basically, the return type and the arguments look the same, but now you also need to specify party : star before the name of the pointer to know that this is a pointer to the member function from this class. Once you have the pointer, you can either have an object of type party and then use dot star operator in the brackets to be evaluated, and then in the other brackets the arguments, or you can have a pointer and then use the arrow star and then the pointer to call this again in the brackets to evaluate this. Now, when it comes to the static functions, now the type of the function for the static functions is the same as the regular functions. And, like I mentioned, the way you can look at static functions is, I hope no one hates me for this, but it's like a regular function that's within a namespace, except the namespace is the struct itself. I have seen the cases where people use classes with just the static functions as namespaces, complete misuse, but okay. And this is just a comparison. Now, the important part here is the fact that for the member pointer, or a pointer to a member function, non-static member function, to fully qualified, you need to use the ampersand. For the static function, you can, or you don't have to. It's like a regular function. If you try to initialize pointer to non-static member function without using the ampersand, the compiler is going to complain. The GCC and Clang are going to be you're trying to call this static thing, this thing it's static, but it's not actually static. And MSVC actually gives a useful error, which is you need to use ampersand to create a pointer to member. Now, we can go back with this knowledge to our higher order function. If you want to write it out fully, this is how you would write the type. So this function takes a pointer to a function that returns an int and takes no argument. The rest stays the same. Though you still need C++14 because of the auto return type or full deduction. Otherwise, you need to decal type and stuff, and it's too much code for a slide. It is midnight. We are halfway there through the best part of the night. And you're okay, that's nice, but this feels like a clickbait, because what is a static function but isn't a static function? We have not answered it. We've just been beating around the bush mostly. Now, the real question is, what is a static member function but isn't a static member function? I just did not put that in the title because that's too many words for a title. Even this was a bit too much. Well, you remember how there was the implicit this argument that we talked about? Couple of people, namely Bendin, Cybrand, Gasper Ajman, and Barry Razvin, hope did not butcher any of those names, came together and thought, you know what? You know how we have that implicit this? Well, why don't we make it explicit? Why don't we have a language feature where you can explicitly state this argument? Now, we will show the uses of it. There are these great talks that I would recommend you watch if you want to learn more. There was actually one yesterday, if you're at Meeting C++, or 3 weeks from now if you're now here. But okay, time travel, difficult. The point is, check it out. If you haven't, then watch the recording. With this being said, this is the good, useful stuff, meaning this is a party, and I will show you some nonsense that you can do here just because, well, this is all about fun, not really about the details and the useful stuff you can use. So you can have the first argument as...
I need to quickly tell you that this talk unfortunately is cancelled and it's not anymore in the schedule. So unfortunately the speaker is not able to come. But thank you for the shout out. So
okay. Well, unfortunately that one was cancelled. Sad. Although I will mention that when looking at the proposals for the talks for the meeting C++, there was another guy who had basically the similar idea as me, which is Shenanigans with deducing this. And I think he also didn't get through, and I feel so bad, but I would definitely love to talk with him about the nonsense he came up with. But okay, you still have those other resources to look at this. Now, for the deducing this, you can, for the first argument, you can explicitly say this, and it means that this is the object on which you call it, and then you call it self, because self is easier to talk about than this. If it's a template, then you actually get the benefits of the template type deduction and makes some things much easier. However, within the function body itself, you no longer have a this pointer, but you have the this argument that you stated is this, and you see how this is very confusing, pun fully intended. And the last thing is that the function pointer to a member function that has explicit this argument is a pointer to a regular function. Now, this comes from the paper itself, and this is an example of having an optional and having to write 4 overloads when you want to return a value based on the qualifiers of the object of optional on which you are calling it. Very difficult to pronounce all that stuff. The point is you need to quadruple your code or come up with other things and copy paste, and then you make mistakes, and not the best way of doing this. With deducing this, you can just have one overload, make this argument a template, and then rely on the fact that the compiler is going to do type deduction, and you can just forward self.m value. And this might make you a bit sad, because we used to have 8 fun, and now this would be just 1 fun. Well, it's valid, but it's, 1 fun. Feels like we're losing, after the loss of volatile, and now this, it's like C++ is just getting less and less fun. And this is a good example, along with the CRTP and recursive lambdas, how you write a proposal to get things into the standard. But if you read between the lines, you realize something very important. You realize that now, finally, we can get this party started. Yes, my friends, this line, now, maybe some of you don't appreciate the fact that this has been more than 40 years in the making. And this is probably the reason why we use this instead of self. It's been foretold, it's been planned, it's beautiful. This is no longer programming, this is art. Looking at the assembly itself, now, well, you see why we have Clang and MSVC, and it's not just because those are the only 2 compilers that supported this feature a year ago when I first did this talk in a local meetup. But we see that the Clang tells us that this part is this, and MSV tells us that this function is actually static function, and it has this unknown thing, which no idea what it is, what's supposed to be, and then there is party, which is never stated to be this. So maybe it's just an error when it comes to this. Now, when it comes to calling this function, well, you can just do p.get. That's fine. But if you want to make a function pointer, well, we've said that it's a pointer to a regular function. So you can initialize it like this, but you should also be able to initialize it like this because it's a pointer to a regular function. And looking at the assembly, this is a static function, and MSVC is going to be okay with this. However, Clang and GCC are going to say no, and they're going to say that you're trying to call a non-static function with the static. So yeah, it's static, it's not static, it's like needs to make up its mind. Then again, we get back to the beauty and the masterpiece that is the invoke, and we just call this function, and invoke knows what to do. It is going to figure it out. Now I understand you are a bit sad, right? We had 8 fun, and now we have 1 fun. It's not a good day for us, and the party is supposed to get more and more exciting and not boring. Well, the thing is, there is no one stopping you from writing this, or this, or this, or this, or this, or this, or that, or that. You can have all the overloads you already had if you want to. And now it's even better because now you are not confused about what exactly you are overloading on. You are overloading on this. It's 1 o'clock, friends. It means you're drunk, very drunk, and I want to go home because now it's just drunk people, and I'm also tired. I want to get some sleep. So I'm like, okay, so listen, that's not how you're supposed to use this. Let's go home. Let's, go get some gyros, shish kebab, whatever is available nearby, get some sleep, get better tomorrow. You, on the other hand, are like, no, my friend, we're just getting started. You see, let's see how far we can actually push this thing. See, they would have you think that, it's about having less overloads and, all that nonsense. But in reality, you can have all the overloads you already had. And you can have more. You can have a pointer to... You can have an overload that takes a pointer, and you can have overload that takes a pointer to a const, and a pointer to volatile, and a pointer to a const to pointer to a const pointer to a const, and pointer to volatile, pointer to const, and like the sky's the limit at this point. But this does bring a question of like, how do you actually call this? Well, okay, the obvious way, if you've been paying attention, is using a function pointer and picking out the overload, the correct overload. But there is another way. There is a way where you can just do this, and I will again give you 2 seconds to figure it out. So, if you remember, back when the night started, back when we were actually discussing where we want to go, I mentioned the overload resolution, and I mentioned that the compiler is going to do conversions if it can and if they make sense. And so one way of doing this is to have a conversion operator. Now, this is going to work only in case where you have only this one overload. Otherwise, you're going to have basically the compiler is just going to call the function that doesn't require any conversions, and you lose your fun. Also, I cannot really take credit for this piece of beauty. This was shown to me last year by, I forgot. I hope it's Andre. If I'm wrong, I will correct somewhere in the chat. A guy from JetBrains who was at the local meetup when I did this first time. Now the time, we don't know the time. We don't know the time because, well, I got my gyros. I went home, went to sleep. You don't know the time because all your possessions got confiscated when you were put in jail. And while you're in there, your amount of blood in your alcohol reaches a certain level, and you realize something else. Now, most of you are probably not familiar. This is from a Serbian movie, and this guy is basically a village idiot, and then he hits his head on a philosopher's stone and becomes extremely wise. And this is when he says, like, new horizons have opened for me. And this ends with him, taking the thinking man pose. What you realize is that, well, this doesn't even need to be a party. This can be pretty much anything. What's the use of this? I have no idea. How you call it? The same way as the the pointer overload, meaning use the function pointer or use a conversion operator. And after I pick you up, pay the bill and all that stuff, we get to talking, and the reason why you ended up in jail is because this still does not compile. Okay. Now you're the compile, the standard says no, you still cannot overload the regular function and a static function with the same name. Even though, okay, I'm not here including the final GIF because it might not be by community standards, but I believe you all know which one it is. And if you look at this, these are two distinct different functions with different signatures. One is a static fun that takes a void. The other is a static fun that takes a party. But I guess that would still break the case where you want to call a static function on an object of the type, because again, the compiler would be confused, especially with this. Like, do you want the object to be used for this, or do you not want? Why does that even exist? I don't know. It's an issue. So what have we learned? Going back from this night out, well, first thing is drink responsibly. The most responsible drinking is not drinking at all, but I believe I know my audience, and don't expect that, but be reasonable. The other thing is getting into fights is not the way to change the standard, and this is especially important because next week, meaning from the week when the meeting cycles is happening, is a committee meeting, and don't do any nonsense. For everything else, there were the links along the way. I will be in the chat for the questions, and the final thing I can say is, wasn't this just fun? Thank you.